and welcome to what to do if the justification step fails. So recall, um, we need a good sampling technique, and the conditions for normality. Of the sampling distribution. To be met in order to run a test. If these conditions are not met, then we should not run the hypothesis test as we are running it. So if the justification step fails, we should not run the hypothesis test. As we have learned it so far. So there are various modifications you can do to hypothesis tests to account for not having normality, or sort of to modify if we don't have a random sample. We will not be learning those modifications in this class. So at this point, we just say we should not run the test because, and then whatever part failed. So for an example, a study was run to determine if more than 3% of US college students wish to go on to get a PhD. A random sample of 200 US college students was found to have 12 who planned to get a PhD. Is there enough evidence to conclude at the 5% significance level that more than 3% of US college students wish to get a PhD? So here's our research question. We're looking to see if more than 3% of US college students wish to get a PhD. This corresponds to a one population proportion test. We have that n is equal to 200. We do have our random sample. It's drawn from all US college students and had 12 wanting to get a PhD. So n is 200, p hat is 12 out of 200, otherwise known as 0.06. Our hypotheses, we are looking to see if the proportion is greater than 0.03. So when we go run our test, we're working with a null hypothesis of p equals 0.03. We have n equals 200. If we do our n times p and n times 1 minus p, so checking for normality, n times p, we are looking at 200 times 0.03, which is 6. N times 1 minus p, we have 200 times 1 minus 0.03, which is 194. So this first one is smaller than 10, it's less than 10. And so our condition fails. So we do not meet the conditions for normality of the p hat distribution, so we should not run our hypothesis test. So we do not meet the conditions for normality of the p-hat distribution. So we should not run the hypothesis test. And that is essentially how we do a problem if we don't meet the conditions that we're needed to meet. All right.